Assalamualaikum student. Now I will explain on example number 6 for the topic mat foundation. Okay, for the question, consider a mat foundation. The size is 30 meter times 40 meter in plan. So in plan meaning that you look from the top. So the size now is 30 meter times 40 meter. Okay, in plan. Okay, as shown in the figure. Alright, the total load and live load on the raft. So the Q is 200,000 kilonewton. Alright. Estimate the consolidation settlement at the center of the foundation. Alright. So now, first, to calculate for the consolidation settlement, SC, so you have to use this equation, to get the consolidation settlement. Alright, so to come out with this equation, so we refer to chapter 2 in your reference book. So I written here, so SC is the primary consolidation settlement, equal to delta E. Delta E is the total change of void ratio caused by the additional load application, over 1 plus E naught. E naught is the void ratio of the clay before application of loads, and HC is the thickness of the clay layer. Alright, okay, so that is the equation for this SC primary consolidation settlement. Right, and then for the normal consolidation clay, so sigma not equal to sigma C prime. So sigma C prime is the pre-consolidation pressure. Alright, so delta E equal to C log delta naught prime plus sigma naught prime plus delta sigma prime over delta naught prime. Delta naught prime ni, here and here is the average effective vertical load on the clay layer. Alright, so you combine both equation, so you get this equation, SCP equal to this equation. Right, so you combine these two equation, then you get this equation. Alright, so you have to find all of the parameter into this equation to get the consolidation settlement for the foundation. Alright, so first you have to calculate for sigma naught prime. Okay, so sigma naught prime ni, change the color. Alright, so I write here, so sigma naught prime equal to H1 gamma sand plus H2 gamma saturated minus gamma W plus H3 over 2 gamma saturated minus gamma W. Right, so substitute all the value. So H1 H1 is here. Right, so H1 now is this one. This one is H1. Right, and then this is H2. Right, so and then this one is H3. Okay, So you substitute all the value, and gamma sen, yeah, here, yeah, is 15.72. Okay, gamma saturated is 19.1, yeah. And then here for the third layer, yeah, gamma saturated equal to 18.55. Alright, so substitute the value into the equation, yeah. So you get sigma naught prime equal to approximately equal to 208 kilonewton per meter square. Alright, okay, so HC, yeah, is 6 meter, CC is 0.28, E naught is 0.9, yeah, here given here the value, yeah, in the equation, yeah. Alright, so HC is the height for the clay layer here. So the HC here is 6 meter. Alright, and then you have to calculate for Q. Q is the net loads per unit area. So given by this equation. Alright, so the Q, yeah, is the loads, yeah, given here, yeah, net load and live load on the rough foundation, okay, is 200,000 kilonewton, yeah, here. And then the size area is 30 meter times 40 meter, also given in the equation here. Alright, okay, and then gamma is 15.72 here, yeah, given in the equation. Okay, and then DF also given in the equation, yeah. DF here is DF, yeah. So definition to measure the length for DF, yeah. So you have to consider the depth, yeah, from the ground level here to the bottom of your foundation. That is DF. Right? Okay, so you solve this one, then you get net load per unit area approximately equal to 135.2 kilonewton per meter square. Alright, so now you have to calculate for the average stress increase, yeah, here, yeah, is the here lah, average stress increase, yeah, delta sigma average prime here, yeah. Okay, so given is equal to this equation lah. Alright, now you substitute all the equation, yeah, the value into this equation. Okay, so now H2, yeah, to calculate for the average, yeah, average shear stress, shear increase, yeah. So now H2 here, yeah, is equal to, you have to consider the H start from the bottom of the foundation, yeah. So now this one, yeah, this one is H1, okay, and then this one is H2. Alright, okay, now H2 equal to this one lah, 1.67 plus 13.33 meter plus 6 meter. That one is H2, yeah, here. Okay, this one is H2, right? Okay, and then H1, yeah, is 1.67 meter plus 13.33 meter. Okay, right? And then H2 minus H1. Yeah, so H2 minus H1. Alright? H2 minus H1. So equal to 6. Yeah? Okay? So now, you have to find what is IAH2 and IAH1. Okay? So to determine this value, okay, so you have to use this figure. Okay? In order to use this figure, you have to find what is M2 and M1 and 2. Alright? So, okay, so refer here. And so the equation to calculate for M2 is B prime over H2. Yeah? Because now it's refer to the corner of the rectangular area. Yeah? So now the size just now is the B is given in equation is 30 meter, right? So B is 30 meter, alright? So B is 30 meter, and then the L, yeah, L is 40 meter, alright? So if you want to calculate, yeah, for the average shear stress at the corner, yeah, so for the B, yeah, so you have to consider B prime. B prime meaning that I wrote here, B prime equal to B over 2. Yeah? And L prime is the L prime, L over 2 lah. Right? Okay? So, L over 2, L over 2. B over 2, B over 2. Alright? So, the B prime is 30. B is 30, right? Divide by 2. So, you get 15 here. Okay? H2, as written here, 1.67 plus 13.33 plus 6 meter. Okay? So, it's H2 lah. Alright? And then, N2, is L prime over H2. Yeah? So, L prime is L over 2 lah. So, 40 over 2. Alright? So, this one is equal to 20. Right? H2 is this one lah, 1.767 plus 13.33 plus 6. Yeah, you get 21. Alright? So, you solve, yeah, for M2, you get 0.71. And N2, you get 0.95. Alright? So, to get this value, yeah, IAH2, yeah, so you have to refer to this figure. Yeah, so M2 is here, yeah, 0.71. Okay, and N2, yeah, N2 is 0.95, right? Here. Okay. So you just here, then project. Okay. So for N2, you use here lah. Alright. This one, this line lah. More or less is this line. Okay. So you project. Okay. Then you get IAH2 equal to 0.21. Yeah. Here. 0.21 lah. Okay. 0.21. Alright. So that one, okay, now we already have IAH2 equal to 0.21. Okay. And then you have to define, you have to obtain IAH2. Yeah. So to get IAH2, you have to obtain the B2 first. Yeah. So B2 equal to B prime, yeah, over H1. Yeah. So H1 is here. Yeah, 1.67 plus 13.33. Okay. This one. Yeah. Oh no, this one. 1.67 plus 13.33. Yeah. So B prime is here lah. Yeah. 30 over 2. So you get 15. Alright. So you solve this one. You get M2 equal to 1. Yeah. And then calculate for N2 is L prime over H1. L prime calculated here 40 over 2, 20. Yeah. And then H1 is 15. Yeah. Here. Yeah. 15. Alright. So you solve. Then you get N2 equal to 1.33. Okay. So from the figure here, yeah, N2 just now is 1. Yeah. M2 is 1. Use different color. Yeah. So M2 is 1. Okay. And N2 is 1.33. About here lah. Alright. So you project. Yeah. So you get 0.225. Yeah. Yeah. 0.2. No. Here. 225. Macam tu. Yeah. Okay. Alright. 0.225. So you have to draw properly. Use the ruler. Okay. Okay. Use the ruler. 0.225. Yeah. 0.225. Right. So now you have the value IAH1. Yeah. So you substitute the value into this equation. Yeah. Average stress increase. So you get the value 23.32 kilonewton per meter square. Okay. And then the last one. Okay. So the stress increase below the center. Yeah. Is 4. Refer to this figure. Center. So you have to time 4. Yeah. 1, 2, 3, 4. Right. So the average stress increase time 4 lah. Right. Here you get 93.28 kilonewton per meter square. Okay. And then you have all the value. Okay. To calculate for SCP. Okay. So substitute all the value into this equation. Yeah. Then you get the consolidation settlement. Yeah. At the center. SCP. Yeah. Equal to 0.142 meter. Yeah. So you change to mm. The settlement, yeah, is 142 mm. Yeah. So solve for example number 6. Okay. So now I finish on the example for the topic foundation. Okay. Thank you. Bye.